Hello and welcome to helpyourmath.com. In this example, we're going to look at even more examples of complex fractions. Before we get started, let's just review my suggested steps on how to deal with these beasts. First, if needed, rewrite the numerator and or the denominator as one single term. And that step is very important because if it's not written as a single term, we're kind of stuck. We can't do a whole lot with the complex fraction. What does it mean for something to be written as a single term? Well, if we have something like x over 3 plus x over 4 divided by 14, the numerator is not one term. This is two terms. We want to rewrite this as one single term. And how do we do that? First of all, complex fractions can be really scary. So I would say just take the numerator and deal with it somewhere else. Go off to the side and say, okay, I have x over 3 plus x over 4. How do I get these to be one term? What are you doing? You're adding fractions. When you add fractions, what do you need? A common denominator. So you would want to find a common denominator. In this case, I would use 12. Multiply so that the denominators have that common denominator of 12. So I would multiply here by 4 over 4. I would multiply here by 3 over 3. And then I would have 4x. So see that I have the same two factors in the denominator, so I can go ahead and add the numerators across the top. And that common denominator would be 3 times 4. This is one single term. So it started out at two terms. Now we have it down to one single term. I can actually even simplify that further and write 7x over 12 all over 14. And then from there, well, let's talk about the next steps. So the next step, rewrite the big fraction bar using the division sign. So here's my big fraction bar. What I would do is I would use that little division sign. So I would rewrite this as 7x over 12. Divided by 14. Since 14 is just an integer, I might put it over 1 because it's nice to have, when there's one fraction, we kind of want everything to be fractions. Next, we rewrite the division of fractions as multiplication by multiplying by the reciprocal of the divisor. So 14 is the divisor. The reciprocal of 14 is 1/14. So I can rewrite this as 7x over 12 times 1 over 14. The next thing we would want to do is we would want to factor any numerator or denominator that is factorable. This example doesn't really have that, so we don't have to worry about that here. Now we would want to simplify and multiply the remaining factors. So what could be simplified here? Well, the 7 and the 14 are both divisible by 7, and the numerator doesn't have anything that would simplify with the denominator, so we would multiply straight across and get x over 24. Okay, so now we're ready. Let's look at some examples. We want to simplify this thing as much as possible. I see that we have issues in both the numerator and the denominator. I have a feeling this is going to take up a lot of work, so I'm going to try to squeeze as much of this in as I can. We're going to start with the numerator. So the numerator, we have 3 over x plus 2 minus 1 over x minus 4. What's our least common denominator here? The least common denominator would just be the product of the two factors because we don't know if they have anything in common, so that's the best that we can do. So I want both denominators to have those two factors, x plus 2 and x minus 4 in them. The first one needs a factor of x minus 4, so I multiply x minus 4 to both the numerator and denominator. And the second one needs a factor of x plus 2, so I multiply both the numerator and denominator by this factor of x plus 2. Now that we know we have the same denominator, I'm going to ignore the denominators for a second. Let's just focus on cleaning up, simplifying, distributing in the numerator. So the numerator of the numerator, I'm going to say num of num. This is what we're focusing on now. We have 3 times x minus 4 minus 1, which I don't need to write, but I do need to include that x plus 2 inside parentheses. It's really important we do that because anything that's a numerator of that second fraction needs to get subtracted. This is one of the places where the most common mistakes occur with these complex fractions and with adding and subtracting rational expressions. Okay, so I have that in parentheses. I know I need to distribute the subtraction. I also need to distribute the 3. So I'm going to have 3 times x minus 3 times 4. Distributing this minus, I get minus x minus 2. Looking for like terms, I have 3x minus x would be 2x. Minus 12 and minus 2 would give me minus 14. I'm going to come all the way over here and just write that over here that I have my numerator of the numerator is 2x minus 14. The denominator of the numerator is x plus 2 times x minus 4. Okay, we dealt with the numerator. Next, we have to look at the denominator. We're going to change the color up just so that it really stands out, because I think sometimes it gets a little overwhelming, especially when there's this much on the screen. Okay, so looking at the denominator now, we have 4 over x minus 4 minus 2 over x minus 2. The first thing we want to do is look for that least common denominator. The least common denominator, again, will be the product of the two denominators, x minus 4 times x minus 2. This guy is missing a factor of x minus 2, so I'm going to multiply both the numerator and denominator by x minus 2. This one's missing a denominator factor of x minus 4, so I want to multiply by x minus 4 over x minus 4. Now what I'm going to do is I'm going to focus on the numerator of the denominator. So here I'm going to look at the num of the denom. I want to clean that up. I want to be really careful. I see there's subtraction. I have 4 times x minus 2 minus 2 times x minus 4. Distributing, oh, this is nice symmetry. Distributing, I get 4x minus 8. Now I have minus 2x plus 8. I want to simplify, so I have 4x minus 2x is 2x. Negative 8 and positive 8 is 0. So the numerator of the denominator is 2x. So I'm going to put this over 2x. And then what was our denominator of the denominator? That would be our LCD here. X minus 4 times x minus 2. Okay, so now we want to deal with the complex fraction. We now have the complex fraction as one single term in the numerator, one single term in the denominator. So the next step is write this using that little division sign, that thing there. So I'm going to rewrite this as 2x minus 14 over x plus 2 times x minus 4 divided by 2x over x minus 4 times x minus 2. We don't want to do anything yet. All we've done is we've taken the big fraction bar and rewrote it with this symbol. Now that we have the division of fractions looking a little bit more normal, we know that we can rewrite this as multiplying by the reciprocal of the divisor. So that's the next thing I want to do. This would give me 2x minus 14 divided by x plus 2 times x minus 4 times, and then the reciprocal will be x minus 4 times x minus 2 divided by 2x. Now we want to factor anything that could be factored. The only thing left, because we already see this guy is factored, this guy is factored, and that's as factored as it's going to get. This numerator here, we have a GCF. 2x and 14 are both divisible by 2. I'm just going to cross this out and rewrite it as 2 times x minus 7. Now everything's factored. Look to see if you can simplify. Let's see, I see x minus 4 in the numerator and denominator. I also see a factor of 2. So this 2 and this 2 will cancel each other out, giving us a final end result quotient of x minus 7 times x minus 2 divided by, what do we have left down here? There's a factor of x and there's an x plus 2. I would leave my final answer like this. I wouldn't do anything special. I wouldn't multiply unless you have to. Leave it like that. Now you might be saying to yourself, wait, there's a factor of x minus 2 in the numerator and a factor of x plus 2 in the denominator. Can I simplify those? And the answer is no. Don't. They don't simplify. They don't simplify to negative 1. They don't simplify to positive 1. They simply don't simplify. Don't touch them. Leave them as they are. We don't know what they are. It's not going to work. Leave your answer like this. All right, how'd we do? So far, so good. Let's look at one more example. Okay, what's going on in our last example? We have a whole lot of stuff. What do we need to do first? We need to rewrite the numerator to be one single term. So we're going to say numerator, and we have x over x minus 4 minus x plus 2 over x minus 2. Let's identify our least common denominator. The least common denominator will be the product of the two denominators, x minus 4 and x minus 2. Rewrite each term so that they have both those factors in the denominator. So this one needs a factor of x minus 2. I'll multiply that to the numerator and the denominator. And this one needs the factor of x minus 4 in both the numerator and the denominator. Okay, so now I'm strictly going to focus on the numerator of the numerator, right? Because the denominator, we're just going to leave it as it is we have the common terms, so we're all set. We just want to clean up this numerator as much as we can. we have x times x minus 2 minus x plus 2 times x minus 4. Distributing here, we get x squared minus 2x. I have to be really careful with this second distribution because whatever I end up getting when I multiply these, I then change all the terms. It's following subtraction, so we want to be really, really careful with that. What I might do is I might just put the whole thing inside parentheses, and that way I won't forget. X times x is x squared. X times minus 4 is minus 4x. Here we have plus 2x, and then minus 8. Now I want to change all the signs in the four terms in the parentheses. So I have x squared minus 2x minus x squared. That becomes plus 4x minus 2x plus 8. Let's look for like terms. Whoops, those cancel. And then we have negative 2x, positive 4x, and negative 2x. Those cancel, right? Because we have negative 4x and positive 4x. Okay, so the 8 is the only thing left. So over here, I'm going to write 8 over, and then our common denominator that in the numerator was x minus 4 and x minus 2. Okay, let's talk about the denominator now. So in the denominator, we want to get this to be a single term as well. We have 2x divided by x plus 2 minus 4 over x minus 2. First thing, let's figure out what that least common denominator of the denominators will be. It's going to be the product of the two, so x plus 2 times x minus 2. Here we need a factor of x minus 2. So I'm going to multiply both the numerator and denominator by x minus 2. Here we need x plus 2. X plus 2. Okay, so now what am I going to do? I'm going to focus on cleaning up the numerator of the denominator. So I'm going to look at the numerator of the denominator, clean it up, and then we'll put it over that common denominator, x plus 2 times x minus 2. What do we have? We have 2x times x minus 2 minus 4 times x plus 2. And I want to be careful with that subtraction as always. Okay, I'm going to distribute 2x squared minus 4x. Then I get minus 4x minus 8. Combining like terms, 2x squared minus 8x minus 8. Okay, so that's the numerator of the denominator. So I'm ready to put this under the numerator. We have 2x squared minus 8x minus 8 divided by that common denominator, x plus 2 times x minus 2. Now we're ready for the next step, which is we have a single term in the numerator, we have a single term in the denominator. Let's rewrite this as division. Using the little division signs, we would have 8 over x minus 2 times x minus 4 divided by 2x squared minus 8x minus 8 divided by x plus 2, times x minus 2. Now I can rewrite it as multiplication by multiplying by the reciprocal of the divisor. So I will have 8 over x minus 2 times x minus 4 times, take the reciprocal, x plus 2, x minus 2 goes to the numerator. And while I'm rewriting this denominator, I know I'm going to have to factor it. I see that all three terms are divisible by 2 because we have 2, 8, and 8. So I'm going to go ahead and factor out a 2, leaving me x squared minus 4x minus 4. This would also be a good time to check, can I factor x squared minus 4x minus 4? And the answer is no. It's so close, but it is not factorable. So we're going to just leave it like that. Now we're ready to look for common factors between the numerator and denominator. I found a pair of x minus 2's, and 8 and 2 are both divisible by 2, so I can simplify those factors. And that's it. So what do we have left? We have 4 times x plus 2 in the numerator. And in the denominator, let's see if I can squeeze this all in. We have x minus 4 times x squared minus 4x minus 4. Just barely squeezed it in. A lot of 2's and 4's here, but nothing else can be simplified. These have been very complex examples of complex fractions. Thank you for stopping by.